In this lesson, I'm going to show you how to name alkenes and alkynes. In the lesson, we are going to name alkenes and then look at dienes. We'll also proceed to look at how to name alkynes. This is a table of functional groups. In the table, we've got the homologous series like alkanes, alkenes, alkynes, haloalkanes, alcohol, etc. Also in the table, there is a structure of the functional group. For example, in the case of alkenes, we recognize that an organic molecule is an alkene by a double bond. In the case of alkynes, the organic molecule is going to have a triple bond. Let's name these organic molecules, right? So these are alkenes. If you look at this one, the first one, it has 2 carbon atoms, and therefore the stem word is going to be it, and the suffix is in. So the organic molecule is ethene. This one has 3 carbon atoms, so the stem word is prop, and the suffix is in. So this is prop in. Okay, let's proceed to this one. So this one has 1, 2, 3, 4 carbon atoms. So the stem word is bute. Okay, the suffix is going to be in, but if you look carefully, you can see that this double bond here could be in more than one position. So in this case, the double bond is on the first carbon. If you name the carbons, this carbon number 1, carbon number 2, carbon number 3, carbon number 4. So the double bond in this case is on carbon number 1, but the double bond could be here on carbon number 2. So now the double bond could be on more than one position. So it means now we need a number to indicate where the double bond is. So in this case, it is on carbon number 1. So I'm just going to say this is bute 1 in to indicate that the double bond is on carbon number 1. Okay, so if we look at this one, the difference between this last one here is that the double bond is no longer on carbon number 1. Okay, so but to name, maybe we should look at the rules for naming alkenes before we name this organic molecule. Okay, so here it says number the longest chain of carbon atoms from the end nearest to the double bond. Okay, so this is how we are going to number the chain of carbon atoms. We number it from the end nearest to the double bond, and we also need to make sure that the double bond is included in the longest chain. Okay, so now let's look at this one. So what we do, we identify the longest chain with the double bond. So this is the chain of carbon atoms with the double bond, and now we need to choose the numbering. If you look, you can see that we've got red numbers, meaning the chain of carbon atoms have been numbered from right to left, and it's also been numbered from left to right with the green numbers. Okay, so which numbering is correct if we were to choose? If we choose the numbering, is it the red numbering or the green numbering? Okay, according to the rule, it says we must number the chain of carbon atoms from the end nearest to the double bond. Okay, so now if we look at the green numbers, we can see that the double bond is going to be on carbon number 3. So if we count, this is going to be carbon number 1, number 2, and number 3. Okay, so but if we look at the red numbers, the double bond is on carbon number 2, because this will be carbon number 1, this is carbon number 2, and then we encounter the double bond. Okay, it means now the red numbers is the correct numbering here, because it gives the double bond the lowest possible number. So we go with the red numbers, meaning the double bond is on carbon number 2. Okay, so now we are ready. We can go ahead and name this organic molecule. So how many carbon atoms are in the chain? We have 5 carbon atoms. 5, that is going to be pent. Okay, so now we need now to tell people where the double bond is. If we look at the red numbering, we can see that the double bond is on carbon number 2. So this is pent 2 in. This is the name of the organic molecule. So now let's go ahead and name this one here on the right hand side. So if we follow the rules, we must first identify the longest chain of carbon, and within that longest chain of carbon we must have the double bond. So that means now this one here, if I go straight like this, although I have 1 2 3 4 5 6 carbon atoms, this is not the longest chain of carbon atoms because it doesn't include the double bond. So I must identify the longest chain of carbon atoms, and in the chain include the double bond. So if I go like this chain is going to include the double bond. How many carbon atoms I have in the chain? It's going to be 1 2 3 4 5 carbon atoms in the chain. What if I went like this? Let me use a different color. What if I went like this? Okay, even though this chain includes the double bond, but it's not the longest chain, because this one will have 1 2 3 only 4 carbon atoms. So it means the longest chain of carbon atoms is the one that I indicated just now. Okay, so let me erase this. So we begin to number the carbon atoms, but according to the rule we must number from the end nearest to the longest chain, to the double bond, I mean. So this means this is carbon number 1, and this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5. And we can see that the double bond is on carbon number 1. So, and we can therefore say, all right, this organic molecule has a branch. This one is going to be an alkyl group attached to the parent chain. So we can go ahead and name this organic molecule. You can see that this is ethyl on carbon number 2, so 2-ethyl. So the name of, remember, if we have an alkyl or a branch, we start by we add a prefix. We start by writing prefixes, and then the stem, and then the suffix. So we follow this rule. We must write a prefix, the stem, and the suffix. So the prefix is the alkyl group. So in this case, it's going to be 2-ethyl. And then the stem, how many carbon atoms we have in the longest chain? So this is 5 carbon atoms. So this is going to be pent. And then the suffix is the saturation, whether we have single bonds, double bonds, or triple bonds in the molecule. So in this case, we have a double bond. So the suffix is going to be in. But we also need to tell people where that double bond is on the molecule. So it is on carbon number 1. So we're going to say dash 1 in. Let's proceed to dienes. For dienes, di means 2. So dienes means 2 double bonds in the molecule. So you identify the longest chain of carbon atoms containing both double bonds. So both of the double bonds must be within the longest chain of carbon atoms. Number the longest chain such that the double bonds get the lowest possible numbers. So that means you can do the lowest sum there. The suffix is a diene, and the positions of the double bonds are indicated separately before the suffix or before the stem word. Okay, let's name this compound. Number one, we are going to identify the longest chain of carbon atoms, and both the double bond must be in that carbon chain. So it means this is our longest chain of carbon atoms. Note that I cannot say this is the longest chain of carbon atoms. I cannot go like this because the red chain does not include this double bond. Okay, even though if I look at the red chain, you will have 1, 2, 3, 4, 5, 6 carbon atoms. If you look at the purple chain, you have 1, 2, 3, 4, 5, also 6. So 6, 6. Which one do we choose? According to the rule, both double bonds must be within that chain. So the red chain is incorrect. So let me erase. Okay, so now we've identified the longest chain of carbon atoms that include both double bonds. So we can then identify this small chain as a substituent or an alkyl group, and we can see it has 2 carbon atoms, so we identify it as ethyl. Okay, so now we can number the chain and then make sure that the double bond gets the lowest possible numbers or the lowest sum. So if we number from left to right, we will have 1, 2, this is carbon number 3, this is carbon number 4, carbon number 5, and carbon number 6. Okay, so if we number from right to left, this is going to be carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and then lastly carbon number 6. Okay, so which numbering is correct? Is it the purple one or the red one? So let's find out. If we look at the purple one, so the first double bond we encounter on carbon number 2. So I'm just going to say, okay, we encounter a double bond on carbon number 2, and we also encounter another double bond on carbon number 5. So we can say this is 2 plus 5 there, giving us 7. If we go to the red numbering, we encounter the double bond on carbon number 1. First carbon, we encounter a double bond, right? We also encounter a double bond on carbon number 4. So if we add the sum is 5. So we can see now that the numbers are smaller if we look at the red numbering. So the correct numbering is from right to left, the red numbering. So I can erase this one. Maybe I can also erase the purple numbers so that I don't confuse myself there. Now I can see that my branch ethyl is on carbon number 4. So this is going to be 4 ethyl because it is on carbon number 4. I can now name this organic molecule. Remember how we name an organic molecule? You just need to write the prefix if they are substituents, stem, and then suffix. So in this case, our prefix is 4-ethyl. Okay, so our stem is going to be hexa. Remember, according to the rule, before we add the suffix, we must bring an A. So it is hexa. And then for the suffix is a diene, but we must indicate the positions of the double bonds separately. So where are the double bonds on the carbon chain. So we've got a double bond on carbon number 1 and we have a double bond on carbon number 4. So we're going to say dash 1 comma 4 dash diene. This is the name of our organic molecule. Okay, let's proceed to alkynes. Alkynes, the suffix is going to be YNE. So let's name this one. 2 carbon atoms, eth, so this is going to be ethyne. 3 carbon atoms, 1, 2, 3, so this is going to be propyne. 4 carbon atoms. Now, once we have 4 carbon atoms, you can see now that the triple bond could be here. It could be somewhere else, but it could be on carbon number 2. But in this case, the triple bond is on carbon number 1. It is on the first carbon there, right? So we're going to go ahead and say this is but dash 1 ine. Now the number which indicates the position of the triple bond is important now, because this triple bond could be on carbon number 2. So now we just need to tell people where it is on the carbon chain. All right, so now let's look at this one. The difference between this one and the rest of the others is that the triple bond is on the second carbon there. All right, so we can proceed and look at the rules for naming alkynes. Right, so the rule says we must number the longest chain of carbon atoms from the end nearest to the triple bond, and the triple bond must be included in the longest chain. Okay, so now our organic molecule has already been numbered. Okay, so we have the blue numbers and the red numbers. So we just need to decide which numbering is correct. Is it the blue one or the red one? So if you look at the blue one, you can see that we encounter the triple bond on carbon number 2. If you look, so the blue one, it's carbon number 2. If you look at the red one, we encounter the triple bond on carbon number 3. So which carbon gives the triple bond the lowest number? So it is the blue numbering. So we're going to let me cancel this one. We are left with the blue numbering. So the triple bond is on carbon number 2. So we can say now, let's go ahead and name this one. There are no prefixes because we don't have any substituent. So we're just going to write the stem and then the suffix. So the stem is going to be pent because we have 5 carbon atoms. Now we need to tell people where the triple bond is. The triple bond is on carbon number 2, so it's pent 2 ine. Okay, so now let us name this one. This one is an alkyne, but we are going to have substituents here. Right, so our first step is to identify the longest chain of carbon atoms. Right, so let's look at this one. If we go straight like this, so how many carbon atoms we have in the chain there? 1, 2, and maybe let me just number them. So we'll have 1, 2, 3. There's a 4th one here, 5, and there's a 6th one next to it, 6, 7, 8. Alright, so we have 8 carbon atoms, and the chain includes the triple bond, so we are good to go there. So we could also number this from right to left and say this is 1, 2, 3, 4, 5, 6, 7, 8. So now we need to decide now which numbering is correct? Is it the purple one or the red one? Right, so the rule says the triple bond must get the lowest number. So which numbering gives the triple bond the lowest number? Is it the purple one or the red one? If we look at the purple one, the triple bond is on carbon number 4. If we look at this is the purple one, the triple bond is on carbon number 4. So if we look at the red one, the triple bond, right, is also on carbon number 4. So now it is clear that this doesn't give us a choice, because we encounter the triple bond on carbon number 4 if we consider the purple numbers, and also if we consider the red numbers, we encounter the triple bond on carbon number 4. So in this case, what do? We carry on, we proceed, and we look at the branches. So the branch here is methyl, right? So now it means now preference must be given to methyl, because this must get the lowest number. So which numbering gives methyl the lowest number? Is it the purple one or the red one? Okay, in this case, if we look at the purple one, the methyl is going to be on carbon number 3. If you look at the red one, the methyl is going to be on carbon number 6. So we are going to go with the purple one. This is going to be 3 methyl. Right, but if we look at the red one, this will be 6 methyl. So we choose to have 3 as the number for methyl instead of 6. Right, so now please note that this is methyl and this is another methyl, so we are going to have dimethyl. So we're going to sorry about that, we're going to name this as 3,3 dimethyl. Okay, so now let's name this. We are going with the purple numbers. So remember, we list this prefix first, and then the stem, and then the suffix. So we are going to say this is 3,3 dimethyl. And then for the stem, this is oct. And then we also need to say, tell people where the triple bond is. So the triple bond is on carbon number 4. So oct for ine. All right, this takes us to the end of the lesson. Thank you very much.